So, up till this point, we've been representing a graph by a single equation involving the two variables x and y. Today, we're going to look at situations in which it's useful to introduce a third variable to represent the curve in the plane. To see the usefulness of this procedure, consider the path followed by an object that's propelled into the air at an angle of 45 degrees. If the initial velocity of the object is 48 feet per second, it can be shown that it follows the parabolic path given by y equals negative x squared over 72 plus x. So you see there it says it's a rectangular equation. Those are the equations that we're used to. Solve for y in terms of x. However, this equation does not tell the whole story. Although it does tell us where the object has been, it doesn't tell us when the object was at any given point on the path. So to determine this, we introduce a third variable, t, and that's called the parameter. We'll see some that have theta instead of t, so we're talking about angles, but a lot of them are in time. By writing both x and y as a function of t, we obtain the parametric equations x equals 24 square root of 2 times t, and y equals negative 16t squared plus 24 square root of 2 times t. If we solved one of these for t, let's say we solved this equation for t and substituted it in here, we'd end up with the same equation that we had up here. But these give us a little more information about the situation. So we're going to look at a simpler equation to graph. We're going to do this by hand first, and then I'll show you how to do it on the calculator. And then we're going to compare it with another graph in just a second. So let's take a look at number one. We're going to graph this. So we need a table with t, x, and y. So our t values, notice it gives us some parameters here. We're going from negative 2 to 3. So we're going to have negative 2, negative 1, 0, 1, 2, and 3. We're going to use those values for t in our graph. And each one of those times is going to give us a specific point. So if we use negative 2 for t, if we substitute that into the equation for x, we get 4 minus 4, which is 0. And if we put negative 2 into t for the y equation, we end up with negative 1. So we're going to have a point at 0, negative 1. Put negative 1 in, we're going to get negative 3 for x and negative 1/2 for y. So negative 3, negative 1/2. Alright, put 0 in, we're going to get negative 4 and 0. Put 1 in, we're going to get negative 3, positive 1/2. Put 2 in, we're going to get 0 and positive 1. And then if we put 3 in, we're going to get 5 and 3/2. So we have a point at 5 3/2. So what we end up with here is a part of a sideways parabola. That's the path that we're graphing here. Now let's take a look at how would we do this on our calculator. Well, one very important thing with your calculator is you have to change modes. If you go to mode, right now your calculator is probably in function mode. We want to change it to parametric mode. And when you do that, if you look at your y equals, it's going to look a little different. Right? It's going to have x1, y1, x2, y2. So we have to put two equations in, one for x and one for y, in order to get our graph. So let's go ahead and put in our first function. So for x1, it was t squared minus 4. If you hit that x button, now it's going to show up as a t. So we have t squared minus 4. And for y1, we have t divided by 2. But before we graph this, we have to set up that parameter. We were going from negative 2 to positive 3 for t. So to change that, we have to go to the window And now you have a T-min, T-max, T-step, and a T-paint. Oh no, there's no T-paint there. So we have to put in a T-min. For this one is going to be -2. T-max is 3. And your T-step is just 0.1. That's fine. You can just leave it as 0.1. Alright, now if we go ahead and graph this, we get our little part of a sideways parabola. Now, I want you guys to go ahead and graph number 2. So, go ahead and change your equation, make sure you change your parameters, and we're going to talk about the differences and similarities between graphs 1 and 2.